Today's lesson will focus on vertical angles. So today we're talking about vertical angles, and vertical angles are formed by intersecting lines that have equal measures. All right, so let's look at some vertical angles. Okay, this tells us that EH and GH are two lines that intersect each other and form four angles. So EF. EF, and here is GH. So these two lines intersect and form four angles. We have angle A, we have angle B, we have angle C, and we have angle D. All right, so let's look at some vertical angles. Okay, this tells us that EH and GH are two lines that intersect each other and form four angles. So EF. EF, and here is GH. So these two lines intersect and form four angles. We have angle A, we have angle B, we have angle C, and we have angle D. Now, these are two intersecting lines, and we can see that angle A and C are vertical angles. We're going to prove that they're vertical angles in just a minute, because remember that vertical angles are formed when the intersecting lines have equal measures. So we're going to prove that A and C have equal angle measures. And angles B and D are vertical angles. They have angles of equal measure, and we'll prove that as well. Okay, in order to prove that A and C are vertical angles and B and D are vertical angles, we have to remember our rule about angles on a line, right? Angles on a line must have a measure of 180 degrees, right? A straight angle, 180 degrees. So angles B and A, when added together, must have a measure of 180 degrees. And that's where we start with proving this point, that measure A, or the measure of angle A and the measure of angle B must equal 180 degrees. Now we can also look at angle B and angle C. Angle B and angle C are also on a straight line. And so let's get another color here. If we see B and C are on the straight line of EF, and so the measure of B and C, let's pick a thicker marker here. The measure of angle B and C must also be 180 degrees, because those two angles are on a straight line. They come together to form a straight line. So the measure of angle B and angle C are also 180 degrees. So this tells us that the measure of angle A plus the measure of angle B, so the measure of angle A and the measure of angle B must equal, so that's this angle right here, must equal the measure of angle B, B and C. Measure of angle B plus the measure of angle C. So this tells us that the measure of angle A must be the same as the measure of angle C. And so that proves that intersecting lines have vertical angles that have the same measure. So those are called vertical angles. Now if we look at the measure of angle A plus the measure of angle B, because this is on a straight line, or those angles are on a straight line, the measure of angle A plus angle B must equal 180 degrees. And if we look at the measure of angle A plus the measure of angle D, because those two angles are in a straight line, they also equal 180 degrees. So what does that tell us? That tells us that, did you guys hear my panting dog? Good gracious. He's really excited about math today. All right, the measure of angle A plus the measure of angle B. I'm going to erase this so you can see. So this proves to us that the measure of angle A plus the measure of angle B has to equal the measure of angle A plus the measure of angle D. Measure of angle A plus the measure of angle D. So therefore, B and D must be the same measurement. And so that proves again, or it also shows, that vertical angles formed by intersecting lines have equal measures. Now we're going to use this to help us find the measurement of a missing angle. Now let's further prove this with the use of a protractor, with actually measuring these angles. So we're going to start by finding the measure of angle P. And so I'm going to line this up, and then I'm going to rotate it around. And I can see that the measure of angle P, if I start here with 0, or the ray is passing through 0 on the outside scale, I'm going to use the outside scale to measure, and I can see that the angle P has a measure of 60 degrees. So let me write that down, 60 degrees. And the measure of angle Q, let's find that next. Okay, so get this lined up. And I can see that 0 is the ray is passing through 0 on the inside scale. So I'm going to use the inside scale to measure this angle. And angle Q is at 120 degrees. And now let's measure angle R. We'll rotate this around. Line that up on the center. And for angle R, the ray is passing through 0 on the inside scale, so I'm going to use the inside scale to measure. And angle R is, look at that, 60 degrees. And finally, let's measure the angle S. This ray is passing through 0 on the inside scale, so we're going to use the inside scale. Oops, I'm losing there we go. And so the inside scale, it would be 120 degrees. So look at that. We just proved that vertical angles have equal measure. So angle Q, look, 120 degrees, which tells us angle S is going to be 120 degrees. Angle P is 60 degrees, so angle R must also be 60 degrees. So which two pairs, or what are the two pairs of vertical angles? Angle Q and angle S, and angle P and angle R. Those are our two pairs of vertical angles. So now that we know that vertical angles have equal measures, and we know angles on a line have to have a total measure of 180 degrees, we can use those two pieces of information now to help us find unknown measures of vertical angles. So this starts off by telling us that WX, oops, let's get back to our pens here. WX and YZ are lines. And they are asking us to find the measure of the missing angle. So we need to find the measure of angle WOZ, the measure of angle WOY, and the measure of XOY. So those three measures. So when you look at this, we have one angle measure, right? We have This measure is 43 degrees. So there's two things that this can help us figure out. One, the opposite angle must have the equal measure. So right off the bat, we can tell that WOY is going to have a measure of 43 degrees. Then if you look, you can see that YZ is a straight line. And so because we know that this angle of 43 degrees plus this unknown angle must have a total measure of 180 degrees. So if the whole has to be 180 degrees, we know that part of it is 43. The missing part we can find out easily by subtracting. So we get 137 degrees. And if this measure XOY, if that angle is 137 degrees, then the opposite angle must also be 137 degrees. So you can see how knowing that vertical angles have the same measure and angles on a line must have a total measure of 180 degrees. You can see how using that is very helpful when you're finding unknown measures. Okay, your turn to think through one. I'll get you started and then I want you to think through it. So line AB and line CD are lines and they intersect. So we know that they form vertical angles. So think about what you know about vertical angles. Think about what you know about angles on lines. And see if you can find the measures of angle J and angle K. It's a little bit dark. Let's try that again. Angle J and angle K. Pause the video, think through it on your own, and then check back to see if your thinking matches mine. Okay, so the first thing you probably noticed is that this vertical angle, because AB intersects line CD, that this vertical angle has to measure or has to be the same measure as this vertical angle because they are opposite angles. And so we know that angle K plus 52 has to have a total measure of 120 degrees, okay? So if we were thinking about this as a part whole, okay, that whole angle has to have a measure of 120 degrees. The part that we know is 52. The unknown amount is going to be the measure of angle K. And so to figure that out, we just have to subtract 52 minus 120. And so that gives us 68. So angle K must be 68 degrees. Now to find the measure of J, if you look to see, these three angles are all on the line, the straight line DC. So that tells us that 68 plus 52, oops, let me change over to the pen here. Okay, that 68 plus 52 plus J must all equal 180 degrees. So if we think about this with our part whole, the whole angle measure is 180 degrees, right? Because it's on a straight line. The two parts we know, one part of that angle is 68 degrees, another part is 52 degrees, and the other part is unknown. So my plan for solving this would be to add the two known measurements together and then subtract that from the total amount. So 68 plus 52, 120. So that missing angle J must be 120 degrees. So in today's lesson, we learned that vertical angles are formed by intersecting lines, and these vertical angles have equal measures. Those vertical angles are opposite angles within those intersecting lines. And we also learned that we can use the fact that vertical angles have equal measures and the fact that angles on a line must equal 180 degrees. Using those two pieces of information, we can find the missing measure of angles.